Before going to give the lecture by Dr. Ravi Shankar sir, I would like to introduce Dr. Ravi Shankar garu. At present, he is working as an associate professor in the Department of Mechanical Engineering, IIT Tirupati. Before joining to Tirupati, he worked as an assistant professor in IIT Guwahati. He did his Bachelor of Technology from SV University Tirupati and MTech PhD in IIT Kanpur. His research group focuses on micro nano manufacturing, sustainable manufacturing, precision 3D printing, online monitoring, biomanufacturing, coatings, tribology, and rheology. His lab also involves in development of lab scale innovations to commercial manufacturing products. He has published over 60 internationally reputed journals, 100 international conferences, 6 patents, 2 edited books, and more than 10 book chapters. The knowledge transfer of his patents is already transferred to India's leading research laboratories such as CMTI Bangalore. Presently, his lab possesses with various funding from BAR, DST, DRDO, MITI, Bayer, SERB, Imprint, IIT Guwahati, IIT Tirupati of about 4 crore rupees as a principal investigator and more than 75 crores of rupees as a co-investigator. He has guided 5 PhD students, 25 MTech, and 30 BTech students. At present, guiding 10 PhD students, 4 MS in research work, and 5 MTech students. Currently, he is a reviewer of over 10 technical journals from Nature, Elsewhere, ACS, Springer, Wiley, InterScience, and Sage publishers. He is the editorial member of IMEC Journals of Micro Manufacturing and guest editor for International Journal of Precision Technology. He is a recipient of prestigious awards such as Institute of Engineers India Young Engineers Award 2005 in Production Engineering, Indian Society for Advancement in Materials and Process Engineering 2011, and a finalist of Indian National Academy of Engineering Young Engineer Award 2014. He and his students received 3 Best Paper Awards in national and international conferences in India and abroad. His students got 3 Best Poster Awards in national and international conferences. Apart from academic awards, he also received Institute Plus Outstanding Sports Personality of IIT Kanpur for his games and sports achievements. So, Sar Morley belongs to Maidupur location, a part of Kadapa district. So, with his love of passionate of this area, he moved from IIT Guwahati to IIT Tirupati. So, this gives a little glance about his biodata. Now, I request Professor Dr. Ravi Shankar Garu to deliver the lecture. Thank you. Ravi Shankar sir.
Thank you, Professor. I'm sharing the screen. Am I audible properly?
Yes, sir. Audible, sir.
Is the screen visible clearly?
Yes, sir. It is visible.
Yeah. Thank you, Professor Damodar Reddy Garu and other colleagues of the department. And then in Global Spectrum, I'm very thankful to the JNT Pulivandal as I was introduced by Professor Damodar Reddy Garu. So as I said, that I always privileged when I was in abroad. We try to think about what we did for our country. Whenever we are in some part of the country, then we think of what we have done for the home state. and whenever you are within the state, you always try to do at least see what I have done for the land where I born and brought up. So as he mentioned that I belongs to the same district, so obviously it's my privilege always that to work or to introduce or to uh, deliberate my knowledge what I gained in some of the years that I was doing my PhD, or whether I was doing postdoc or very little bit of postdoc type of things or project you can say, and as a faculty also. So so today I'm going to talk about one of the areas. See, currently almost all 21 PhDs are working. So whatever the area that I'm going to talk is only one particular student. I'm very thankful to Mr. or currently you can say he is Dr. Rashmi Ranjan Behra. He is basically from Cuttack, uh, Orissa, and he was my student at IIT Gauhati. So currently he's a faculty in KIIT, Kalinga Institute of Information Technology, Bhubaneswar. So I'm going to talk on micro nano bioceramic functionally graded coating. So here there are three terms which are fascinating to the many of you. That is, one is micro, how it converts to the nano, and both this micro and nano are converted in terms of the material that we are using is bioceramics. So whenever we try to talk about the bioceramics, the ceramics are completely different from the with respect to the metals and alloys. So how we are going to coat those materials perfectly and other things. Okay. So at the same time, how we are making it functionally graded, because the function is the only thing how it has to work for your applications. For example, here in this particular applications, what we are going to talk about is orthopedic applications, or you can say in normal terms, you can also say some of the dental applications also. So how we are going to match the bio, micro, nano that you can see in this particular thing for biomedical applications. So as you know that we are in the Rayalaseema region of Andhra Pradesh. Tirupati is one of the prominent cities in the Rayalaseema region, and in as a global spectrum of Andhra Pradesh also, it is one of the biggest cities uh, in a spectrum of India. We come under the third tier cities. Okay, so we are approximately 120 to 130 kilometers away from IIT Madras, and third generation IITs, as you know that we at IIT Tirupati along with IIT Palakkad, IIT Goa, Dharwad, Bhilai, and Jammu, we are the third generation IITs, and we are fortunate enough to move to the campus compared to others in well far. So, for example, I mean to say that we are planning to shift to the permanent campus. Our campus is almost ready, and all the facilities are now gradually housing into their respective positions. So, So regarding the history on milestones of IIT Tirupati, so announcement of third generation IITs, whatever I spoke in the previous slide, was given in 2014, and we started working from 2015. However, some of the third generation IITs started from 2016 also. So we are very fast, and at the same time, what I mean to say is that we are growing very fast compared to even some of the second generation IITs also. So what is the scale bar for it? The scale bar for it is, for example, we are now nearly 100 faculty are there in at IIT Tirupati, and we almost have approximately 75 to 80 number of projects. That shows that how the number of projects in the ratio to the faculty is there. For example, if you take some of the institutions, this ratio may be slightly less. So the one thing that I would like to say is that IIT Tirupati is mentored by IIT Madras, and IIT Madras follow MTech and MS. For example, as you know that all IITs has BTech, MTech, and PhD. Apart from these, we also have MS by research. So what I mean to say is that so those people who are interested to do the research, they can also enroll to the MS. Now, So those people, I'm just telling that like any government organization where you have lab facilities can enroll to IIT Tirupati. If you are a bachelor degree holder, you can enroll as an external candidate to MS, or if you are already a MTech holder, you can go for PhD. And we don't currently we are not considering any gate score or something. So externally, if your institute allows you, for example, just since I am delivering a talk to IIT JNTU Pulivindala, for example, any JNTU Pulivindala person, for example, MS holder is there or MTech holder is there. For example, you want to pursue the higher degree like PhD or something, they are entitled to join IIT Tirupati, subjected to the no objection certificate from the home institute. Okay, so similarly for any type of government organization where it is AICT approved or either MHRD approved, or you can say DST approved or something. Okay, so for that purpose, I will just give you the glimpse of what we do in the today's lecture, some glimpse of research, some glimpse I will give you in the my next class also. Okay. So currently we have 5 engineering divisions. We started with 4 engineering divisions like civil, computer science, electrical, and mechanical. Later on, we added another one department that is called chemical engineering. Okay. So chemical engineering, the first batch of chemical engineering is in the 3rd year currently. And if you take all other departments which just started early, these are all has started approximately. Now 3rd batch has completed. That means that the convocation for 3rd batch is already completed. So coming to the sciences, we have chemistry, maths, physics, humanities, and social sciences. There are 4 sciences. So apart from these, what is the specialty about IIT Tirupati? So if you take IIT Tirupati as in case, what you can say is Department of Material Science and Engineering and School of Design. These are the 2 departments which we are going to start in near future. And coming to the Center for Precision Agriculture and Food Processing, this is already, we have received some of the funding already, and this is going on. Officially not launched, but the work is going on. So what we try to do here, precision agriculture. So as I said again and again and again, that we are in the region of Rayalaseema where water scarcity is very high. So how we can make the agriculture so precise? So for example, so what is our laboratory in particularly we do? So in particular in mechanical department or something, we work on drone based technologies. And the second thing which is slightly relevant to present talk is about the coatings, which we try to make the sensors. For example, so soil sensors are there. So you need to have particular coatings of soil sensing coatings to understand what is the ratio of NPK levels in the soil, for example nitrogen, potassium, and other things. Okay, so you just take the soil and you just prick the sensor inside the soil, so it will tell you what are the NPK levels in that. That shows that maybe give 2 types of data. One, whether what nutrients you need to put based on what is the crop that you are going to decide, or it again give you which is the best suited crop for your field. These are the 2 things. Apart from these 2, we also work exclusively on CRF. So CRF stands for controlled release fertilizers, which I am not going to talk. Just controlled release fertilizers is a latest technology that we develop because we also work into the polymers and other things. So what is it is that, for example, a farmer goes to the fields and throws the urea phosphate, which is a spherical particles. So spherical particles, if you take theoretically, so approximately 60 to 50% or 50 to 60% go as a waste because the sunlight falls, reaction will take place and diffuse off. Second thing is because of the other things and wash out and other things will goes off. So CRF plays a major role, which I am not going to talk, but it is a biodegradable polymer coated NPKs are there. So only this will be depleted into the soil because this will be degraded by the virtue of soil microbes. So soil microbes based CRFs we work. So that is regarding the precision agriculture as per my lab is concerned. So second is food processing. So food processing, you have to look at what is abundantly available around you. For example, Tirupati, we just have abundant amount of mangoes, abundant amount of papaya, abundant amount of bananas and other things, and tomatoes also. So what we try to do for the solution that we try to give them is how to make the nutritious powder without disturbing the nutrients values. For example, if I want to convert papaya milk into the powder, which has a medicinal and which uses by the pharmaceutical companies. In that circumstances, what we try to do is we should not degrade any type of composition. For example, if the milk has certain composition that can be obtained by the FTIR analysis or any analysis, just we need to maintain this consistency to the maximum extent of 98 to 99% of that one. So that is one of the things that we try to do. Simple language, which I can say you is that, for example, so I assume that Pulvindala may have abundant amount of tomatoes. How you can make tomatoes into tomato powder without disturbing or without losing the nutrients. Okay, that is what you can try on and you can get the projects and other things. That is what I mean to say. So next, fourth is TIH, which is a 100 to 120 crores of budget from the DST, Department of Science and Technology, is that precision technologies and positioning. So precision technologies and positioning is all about, currently you talk about GPS. So GPS has its own time limitations and other things. So what we are working is, we as a mechanical engineer, which I work into micro nano. So we try to support the people who want to do quantum clocks and other things. Okay, that is about precision technologies and positioning. So you need to position very perfectly. For example, simple. For example, since tsunami is coming. So tsunami is coming. So normally in the All India Radio, people may say that tsunami is going to touch the soil or the, you can say, the nearby villages by evening 5:30. So sometimes it may come at 6:30. In that circumstances, it is not a problem. If it comes 4:30, it is a problem because the preparations are underway. So you need to track the position. You need to track these positions. To have that, you need to have ultra precision technologies. For example, you need to have high quality lenses, so these lenses and other things we'll try to fabricate. The fifth is CAMOST, Center for Atomic Molecular Optical Sciences and Technologies, where in particular my lab work on laser based micro manufacturing center. Recently we got a funding about 1.5 crores of rupees for laser micro manufacturing, and we also have another funding about 60 to 70 lakhs for optical metrology, which exclusively we have at IIT Tirupati, is that optical 3D surface profile emitter. For example, if you do turning operation or milling operation or the grinding operation, if you want to measure the surface roughness, the basic mistake try to do all the people is they try to have a probe type of surface profiler and they take a value, or they can take a line. So line may not give you perfect results. In the circumstances, what you try to do is we need to try to map the area. So that is called SA. People all talk about RA, so surface average surface roughness value. Now people are talking about average surface roughness, average surface area roughness and other things. Now instead of going for one line, you try to go for area. In future, people may go for volume also. Okay, so these are the two technologies which we work for CAMOST, being a member of the center. So in particularly, what are the areas that I work is micro machining and nano finishing, which I just give you the glimpse. Sustainable manufacturing group, additive manufacturing, smart manufacturing, and bio-nanomaterials manufacturing group. Smart manufacturing, I'm not going to talk because I will explain you in the next lecture. Micro nano manufacturing group. Micro nano manufacturing group, let's just concentrate on what is the micro machining that I try to do here. So we try to do laser-based micro machining process. At the same time, we also have a 5-axis iridium process also. So we have from Charmilis, Agile Charmilis, which is from Switzerland, which cost us around nearly 1.2 crores of rupees. A 5-axis complex shapes cutting you can do, any type of cuttings and other things. And we also going to procure a die sinking medium, which is from a very good brand and other things. So apart from this, we also have the laser micro machining center. As I said, laser micro machining center, we got the funding, and the tendering is also completed, and we have to place a purchase order. So by next summer, it will be with us. So what we can do and what we have done with the lasers is micro machining for stent applications for cardiovascular and other things. Second, for nuclear applications, as you can see, nuclear back and fuel cycle based components, which I cannot explain you much because this is a confidential things, and microfluidics on polymers. And at the same time, you can also see for laser micro machining of fuel injector nozzles. Apart from it, what you can also do is you can do for coating technologies also. So what you are going to do today is coating technologies. So the last one that you are seeing here. So I'm not going to talk much about the finishing because my next lecture will talk on finishing. So I'm not going to talk on finishing. So these are some of the extra slides that I will explain you in the next lecture also. Sustainable manufacturing group. So sustainable manufacturing group, just I will give you some glimpse what we do. So the first glimpse is you can just watch how the machining takes place conventionally. This is the one that I started my research. Sustainable manufacturing, I started in 2002 when I joined IIT Kanpur. Okay, so approximately 20 years back. You can see what is the great potential about it. Yeah, so this is one of the problems. Normally, I cannot say the problems. Normally, in the colleges, people talk about thermal aspects of machining and other things. So to overcome these thermal aspects of machining or the high temperatures that is generated during the machining process, there are two solutions. One of the solutions that normally people talk about is going for diamond cutting tools or ultra hard cutting tools, which is an expensive process for a country like India, because we always talk about what is the economy. For example, whenever we try to go to the shop to get a car or a bike or something, the first and foremost, the Indian mentality, or I cannot say Indian mentality, for example, as the common man mentality, I can say that you just observe how much mileage it will give. So you don't look at what is the safety features it is. Nowadays, people are slightly aware of and other things. In past, or you can say still currently, some of the people thinks about how much mileage, because that is clearly evident from the advertisements in the newspaper. For example, they will write clearly, this particular car will give you 20 kilometers per liter. Why they are writing that? They are writing because people want it. The people want to observe it. The same thing. In that circumstances, diamond-based cutting tools or PCBN or CBN cutting tools are very, very expensive. So you may not satisfy the customers. In that circumstances, what the people try to do is what the people try to do is they will try to go for cutting fluids. In some of cutting fluids, these are the problems. So the basic problems is when the cutting fluid falls in the machining region where the temperature is 1000 degrees or something, see directly emissions will take place. The evaporations will take place, that you can see here. When the cutting fluid is dropped, how the cutting fluid is going to emit the dangerous chemicals and other things. So hope you might have clearly seen this. Okay. So whenever you are trying to do the machining operation and other things, these type of things are commonly one can observe. So now what these emissions will lead? These emissions will lead this type of tremendously, or you can say that dangerous diseases and other things. Okay. So, what are the diseases that will cause? Chlorinac, dermatitis, mild bronchitis, and other things. These are many things that it will cause. So, what you have to understand here is that you need to. What is the solution that our laboratory will do? Our laboratory has a solutions of multiple solutions. Currently, we try to do the green cutting fluids and at the same time minimum quantity cutting fluid, as you all know. So we have different types of minimum quantity cutting fluids. Some of the things that we develop on our own, some of the things which we can procure from abroad also. Okay, so these are the things that we try to do. And the most important thing that we try to do is we try to develop sustainable cutting tools, and we also try to develop sustainable compositions for green cutting fluids. So we are also provide services. As you see, we also provide the services means, see, some of the people nowadays slowly requests are coming through the proper channel only. What is the request is that, sir, can we get cutting fluids? So it is all about the patented technologies and other things. We are ready to supply to the people. We don't have, because some mails are coming from some of the universities in Andhra Pradesh and other states also. So what I mean to say is that we are ready to supply, but through proper channel. So we have to take appropriate permissions from our institute, and we can supply to you also. So because people want ACI publications and other things, so if they what they think is that if they may have chances if they can get the green cutting fluids, so emissions and other things they can understand, and we can also provide you some data. For example, what is this cutting fluid emits and other things also. Okay, so people try to approach us officially also. So another area which we want doing since 2013, second part of, or you can say 2014 onwards, it is called sustainable micro machining, or you can say micro machining using bioorganisms. This is one of the fantastic area that you can observe, and this comes under the sustainable aspects because I can do the micro channels, I can do the micro mixtures and other things by lasers. But problem is the melting and evaporation is the mechanism of material removal. In that circumstances, your wastage of material is going into the air. For example, in this particular case, simple, I have two things that I want to do. One is micro nozzle, that you can see my cursor. This is the micro nozzle, or I want to do a micro mixture. In these circumstances, what I try to do is, first I do the photolithography, or I can just coat and I remove the area where I want it, the things. And the second thing I want to is, I want acidothiobacillus ferroxidans, which is a bioorganism that I can work on. So once I get from a reliable source acidothiobacillus ferroxidans, then I need to culture it, then I need to populate it. So, and you need to understand, this particular slide looks very easy, but it is not so easy, because you need to understand the life cycle, because the performance of a child, performance of a young person, performance of a elderly person is completely different. Same as that. For example, as the bacillus ferroxidin, you need to do this machining at when it is in young age. For example, I gave a particular work, physical work, I mean to say. So physical work I gave to a 10 years boy, 30 years person, and a 60 years person. Who can do much better? The 30 years person will do much better. So you need to understand the life cycle and other things. So once you do, you just put it automatically, as well as the bacillus ferroxidins will try to have a metabolism where Fe2 plus ions will metabolize to Fe3 plus ions, and Fe3 plus ions are strong oxidizers, and it tries to do the biochemical reaction with respect to the surface and try to make out the atom by atom. So what are the advantage of this one is, you can see here, micro mixtures are whatever the exposed surface, you can get this. Apart from this, what you can get in a laser machining or EDM process, you may not get chips. You may get in EDM sometimes if you use the filter and other things, but very less quantity. For example, here you also get nanoparticles. And since you are machining, you are doing with respect to the copper, which is an antimicrobial thing, and you are going to get antimicrobial nanoparticles. That means that nothing is waste here. So you are getting microfluidic channels that you require. Second thing is, the microfluidic channels are delivering you the drug carriers. I mean to say, this is antimicrobial, it is anti-inflammatory, antifungal, antibacterial, antivirus type of drug carriers is copper. So that's why we are happy to say that this particular paper is adjudged as the best paper award in IIT Madras in 2017. So almost it took us 3 years to come to a very good results. So it is also gives microfluidic channels and antimicrobial spectrum. At the same time, it also gives antimicrobial suspensions for particles. So which is a sustainable process, because it gives the 0% waste. I cannot say 0%, or you can say a minimal waste percentage. So additive manufacturing group. So again, so all the areas we are open for any type of support if you require. So exclusively, so we also giving some support in additive manufacturing also. So additive manufacturing, we try to do, currently we have 2 systems. One is polymer system from Stratasys, which is around 30 lakhs 3D printers, which you can print the very minute ones. We are also getting another SLM, which is called stereolithography based stereolithography based gel based 3D printing technologies we are getting. And ceramic 3D printer is there at IIT Tirupati, and we are going to procure a metal 3D printer, for which our authorities has already been sanctioned the amount about approximately 4 crores and other things. So what is the advantage of metal 3D print? Other things are indirectly what I mean to say additive manufacturing. For example, if you see here, one has to clearly understand here. So this is the original design where you have a components, and these components are joined by riveting or any other means. Okay, so this can be understood in terms of the functionality, then topological optimization can be done, and you can build it. So what is the advantage here? So advantage is this is going to use in a space applications. So in a space applications, the basic challenge here is that you are going to have each and every gram is concerned there. So for example, this particular component cost you 1 lakh rupee, assume. So if this particular component cost you 1.5 lakhs also, still space application center people, they will provide you. There's no problem because it is reducing approximately 660 grams, which is a huge burden on a spaceship and other things. That's why, what is the bottom line of the story? The bottom line of the story that you have to carry forward is that where you need to invest the costly processes. For example, the same thing if you want to do for a cylinder development. Cylinder development you can do by extrusion, forging, whatever the conventional casting and other things. So there, your 3D printing should not work because you need to check what is a viable solution and other things. That's why whenever you are going for some of the components that you are putting, whenever we want to get some of the components, 3D printed components and other things, these are very expensive. Simple plate, if you ask a simple plate 10 centimeter by 10 centimeter, the minimum charge they will charge you is 10,000 rupees. The same thing, if you want to get the same material by normal conventional manufacturing route, you can get for 1,000 rupees. So what you have to understand, again and again I'm repeating, is that you have to wisely take a decision which you have to do by additive manufacturing process. So second thing is hydraulic manifolds. Again, if you see hydraulic manifolds, all will have the holes from all the directions. This all the directions has to be merged together at certain positions in certain angles. That is very, very tricky because all these holes are internally joined. As you can see wireframe model, all these are joined at different junctions or different angles. Because of that, drilling all the sites is not a problem. Joining at different angles, for example 45 degrees, 50 degrees, 70 degrees, 90 degrees, it will be nearly impossible or nearly not possible to fabricate. In that circumstances, you can go for topological optimization based on functional requirements, and these functional requirements you can do, and you can develop a 3D printed component. Okay, the common hydraulic manifold will cost you around few lakhs of rupees. Here, the burden on the materials also is going to reduce, and the same time cost also will reduce. So you need to find solutions where you need to employ additive manufacturing. So one of the examples, you can 3D print two structures. One is a solid structure that is here. Another one is a lattice structures. Okay. So why you want to go for lattice structures? Lattice structures, no, you can use material wastage, you can minimize. Both you can print by 3D printing technologies. In that also, people are nowadays working on lattice structures, especially my group. There are few PhD students working on lattice structures for biomedical applications, automobile, lot of applications. For example, if you see here, 5.1 kg material is used and functional surface is 823. You can see here lattice structures, because of the lattice structure, how much material is saved. Approximately 3 kgs of material is saved. So why you want to save the material? Because you have to save the material because your children are there. Your grandchildren are going to come. Your great grandchildren are going to come. And these people want some materials to sustain. So that's why sustainable manufacturing plays a crucial role in terms of additive manufacturing also. So we have, and our collaborators are our students who are working. So they have all these type of facilities. Powder bed system is there, direct metal deposition is there, and other things. As I said, that we also have one of the processes called ceramic 3D printing. You can see some beautiful structures that we try to build using ceramic 3D printing. Only thing is that how and what type of ceramics that you can. Okay, so beautiful structures and other things you can fabricate by ceramic 3D printing technologies at our laboratory. If you want any support or anything, at this point of time, we are not providing any other solutions. 1 minute, I'm just getting an official call. Hello, చెప్పండి. అది ఓకే తిరుమల, నేను చెప్పాను ఆల్రెడీ ప్యానల్కు ఐ విల్ బి దేర్ బై 4:15 అని. నాకు 2:15 నుంచి నా క్లాసు జేటీఎస్ సెలక్షన్స్ ఉన్నాయి కొన్ని. ఓకే, నేను ఆల్రెడీ మెసేజ్ పెట్టాను వాళ్ళకి అందరికి. ఓకే, ఐ విల్ బి జాయినింగ్ అరౌండ్ 4 o'clock. I will be joining. Yeah, so at 4 o'clock I will join the comprehensive examination. Okay, so these type of structures we try today. Now we are entering into the area where we are going to talk today. So the bio-nanomaterials and manufacturing group. So this is a group. We exclusively work into the materials development as well as coating technologies, how these coating technologies are working for us. If it is not working, how we can overcome the problems and other things. Okay, simple. If you see here, what are the artificial bio implants and other things? If you take from the leg to the brain, or you can say head or something, you have lot of components. Currently I'm not going to talk on any type of these things. 1 minute. Official calls. దుర్గా చెప్పు దుర్గా. ఇంట్లో ఉన్నాను. నేను వర్షం పడుతుంటే రాలేదు. అయ్యో సారీ. Yeah, so there are multiple implants. These implants has to interact with respect to the outside body, for example body fluids and other things. Okay, so how one has to fabricate these implant materials coatings. So it is not that much easy to coat. So you may think that okay, so you have a setup and you can do it. No, if you have the setup also, for example, these setups will cost you few crores of rupees. Some setups, for example, plasma enhanced CVD, PECVD, which we are planning. So this particular machine will range from 2.5 crores to 5 crores and other things. So if you have the machine, you cannot do things. Only thing is that you should know the physics of it, you should know the chemistry of it, you should know the biological activity and other things. Once you know all these things, then only a mechanical engineer can start the work. Why? You can see in this particular slide. For example, you have a dental implant. Okay, so normally dental implants, people talk about titanium implants. If you are putting a titanium implant like this, your titanium is a bio-inert material. So bio-inert material means it cannot neither do positive nor do negative aspects and other things. Okay, so what people try to do is they try to do the coatings. So what they want to do is that this type of coatings will help in osteoconduction as well as osteointegration. So what are these osteoconduction and osteointegration? If you can understand the basics of osteoconduction and osteointegration, then you can do proper coating. So for example, if you want osteoconduction and osteointegration, you need to go for a porous coatings. How the porous coatings look like? For example, whenever there is a implantation is going on into the mouth, you need to try to put, first they drill it, then they try to rotate it, and so it will experience the tribology, or it experiences the shear force on top of it and other things. Once you place it, as I was telling in the previous slide, you should have the conductivity of the fluids, body fluids and bone generation and other things. Is it has to conduct through the the coating surface, that is called osteoconductivity. Osteoconductivity is the protein exchange, the mineral exchange has to take place across the coatings. Once during this particular course of time, you need to have some layers development on top of it. So these intermediate layers will integrate the bone, at the same time the coating surface also. That is called osteointegration, for which how the coatings look like, you just see here. So the coatings look like this. You should have a solid coating, an interacting coating, and as you grow across the coating, it has to open up. It has to open up because it has to have the pores as many as possible. Once you have the coatings with high amount of, 1 minute. Is some issue. Yeah. So osteointegration, as I said, whenever you have a porous type of the structure, so the fluids pass through this one. Whenever the fluids pass through, it has to generate a third layer, that is called integral part of the mineral layer and protein layer and vitamins layer, whatever the layers. What these layers are called, sometimes in osteo, they are called as apatite layer. Okay, so those layers will form on this one and joins the body along with the crown. This is called osteointegration. So for the osteointegration, the best choice is that you should have proper osteoconductivity. So some of the people also uses zirconia based implants and other things. Now we move on. So first and foremost, whenever you want to coat, is that what you want to coat and why you want to coat. Okay, is your coating material is good? That question comes in the next. So what I want to coat? I want to coat a calcium phosphate. For example, your bones, dental implants and other things, everything will have calcium and phosphate. So this calcium and phosphate is, for example, Ca10PO4 whole power 6 OH twice is hydroxyapatite, which is one of the bone material, or you can say artificial bone material. Now I want to coat. So you may get doubt, why sir, why you want to coat? Directly you can make an implant. The basic problem is it having a poor mechanical properties and other things. Hello? Tell me. Class lo na talli nuvu. Okay, so what is the thing is that you should, if you are having a brittle materials like this, so what this brittle materials is, it may break. For example, you have a glass, so it may break. So what you require is, you require some ductile material which has a bio-inert nature for providing the mechanical strength. For that purpose, you try to take titanium alloys. So titanium alloys are bio-inert material, neither it will do positive nor it will do negative and other things, but it will have a good support. Okay, that's why you have pros and cons of both materials, and these pros and cons, what are the advantages that you are going to club. So titanium has a bit mechanical strength and other things. At the same time, it has a poor bioactivity. To enhance the bioactivity, you need to take hydroxyapatite and coat on top of it. So now you can do these two things, and what you are going to get is coatings on hydroxyapatite and titanium alloy, which enhances the superior mechanical performance of the metal and with excellent bioactivity of calcium phosphate. This is the aim and objective. Now I want to make a implant, or you can say dental implant or a bone implant, any implant which has a good mechanical strength. At the same time, it should have good bioactivity also. Okay, so now the question comes, whether the material that I'm developing is good or not. So for that purpose, how you have to fabricate the bioactive glass or hydroxyapatite, or you can say the biomaterial that you are talking about. Since this particular work is started in 2012, at the time I was in IIT Guwahati. So IIT Guwahati comes in the region of Northeast, where people takes abundant amount of fish. So now, so fish scales are abundantly available and free of the cost. So we can take the fish scales. Fish scales contains abundant amount of calcium and phosphate. In that circumstances, what we try to do is how to extract that. Fish scales also contain some protein, but that protein is entirely different from what the protein that humans require. That's why you need to do deep proteinization, or you need to remove the proteins and other things. That's why what we have done is acidic deproteinization followed by basic deproteinization. Then we have gone for calcination process. So once you do the calcination process, you get the flakes of hydroxyapatite. Then you can go for ball milling applications, and you can do the as per your requirement of the particle size. If you are looking at the normally small institute level, up to this microparticles is okay. For example, if you are looking for nanoparticles and other things, then you have to extend for slurry, sonication, freeze drying. So these are the processes that this will escalates enormously up the process and other things whenever you talk about the nanoparticles. But my thing, what the suggestion that I can give you is that you can, if you want to do the, you can follow the first row where fish scales to up to the ball milling, where you can get a microparticles. So once you get, you need to start characterizing whether I received a good material from the manufacturing process or a production process or not. That was is a $1 million question to ask about. For example, if you are calcinating at 700 degrees. So what we have done is we have done from 700 degrees to 1400 degrees. Since we have less space, that's why we are showing you only some here. Okay. From the images, it is very difficult to predict whether this material is good or not, just for you qualitative understanding. So we are not telling you quantitatively, we just wish to tell you which is good or which is not good. For example, if you see 700 and 800, you need not to do for high level characterizations like XRD, FTIR and other things, because by default from the visual inspection itself, you can understand that this is not good, obviously. So you can do, but you can avoid some of the things. That shows, for example, if you see here, the first and foremost that you can do is you can go for FTIR analysis, Fourier transform infrared spectroscopy. It is one of the IR technology. So FTIR, one curve, I am just going to explain at 1250 degrees. As you can see here, a lot of things are there where you can see OH bonds, PO bonds, and CO bonds, calcium, phosphate, and OH bonds and other things are predominantly available. Now, we are going to do at different temperatures, for example, 800 degrees to 1400 degrees. So it will show you what are the compositions and bonds available in the materials. Okay, this is one type of characterization to understand whether the materials has proper bonds. PO bonds are there, so phosphate is there, calcium is there or not, and other things. Apart from it, you also have to go for XRD analysis, where you can also different 2 thetas. You all know Bragg's law, n lambda equal to 2d sine theta, where 2d 2 theta will be there on x-axis, and it will give you some of the Bragg's and other things, where you can see where tricalcium phosphate is there, beta tricalcium phosphate is there, and other things at different. So once you understand these two, you can also have to understand in terms of ball milling time. See, whatever you are doing from a fish scale after making a hydroxyapatite. So once you have doing, you need to do a ball milling with respect to number of time. So if you are doing a ball milling operation, there will be a contamination comes because balls are there, bowls is there and other things. So you need to do again with respect to different ball milling time, like 2 hours to 9 hours at the same time XRD also. Now you have a big data. I have a powders. So these powders has this type of characterization and other things. Now, whether which is good for me, whether the 2 hours is good or calcination temperature 1150 is good. So what is good? Those things you need to understand. So in our case, normally what we got is 1250 and 1200 approximately gave the good results. So once we got the good results, so what we have to do is we have to understand the purity of the material. So for the example, if I want to understand the purity of the material, so there is a standard pattern that you can do is JCPDS in a XRD library. For JCPDS, you will have a standard curve. For example, hydroxyapatite, you will have a standard curve. On the standard curve, you need to superimpose your data. So for example, my 1250 degrees, which is giving me good results, I am superimposing. Once you superimpose, you have two methods to quantify the purest form of the materials. So whatever you are seeing at the bottom, 2 degree, this where my cursor is there, this is called JCPDS data, where it shows 99.999% pure. This is a standard library available in XRD. So whatever the blue one that we got is that from our material. So once you remove the base, you try to superimpose this. So you have two methods. One is peak intensity method, from which you can guess qualitatively what is the purity of the material, whether it is 99% pure or whether it is 90% pure or whether it is 60% pure or something. Since it is a biomaterial, you should always will try to make it 99.2 or 99.5 and above. So in that circumstances, what we have done is that you can also go for another analysis that is called Redwelt analysis. So these two methods will give you what is the purity of your material. Since this, again, I'm repeating, this is for bio applications and that to internal applications. So you need to be very careful about the purest form development of the material. So that's why what we have got is approximately 99.5% pure. And at the same time, you also should have to maintain calcium to phosphate ratio. Assume that you have a very good amount of calcium, but a very less amount of phosphate. So in that circumstances, it will be very problematic because osteoporosis and other things will come. So you need to maintain not only the purity, you should also maintain calcium to phosphate ratio. The calcium to phosphate ratio should be in the range of 1.65, or you can also go for 1.64 to 1.68. So we are on edge of 1.65. We are on the competitive mode. At the same time, you can see the particle size. Particle size analyzer also you can use, and normally the particle size is near to 350 to 400 in between. So you can see the surface morphology of the particles. This is the surface morphology of the particles. And as I said, we try to do the freeze drying, sonication and other things. That's why the particles, we can still go below certain nanometers also. For example, in this case, we have gone up to 20 to 60 nanometers. As you can go towards the nano, what is the advantage you get? The advantage going to get is your surface area will increase. At the same time, you can see whenever you are going for nanoparticles and other things, from 360 to 20 to 40 or something, whatever you can say, the calcium to phosphate ratio is slightly better. I can say 1.67 is normally a healthy human will have 1.67. So we are on par with respect to purity as well as the quality of the materials. Once you have, so we used to have one professor, Professor Rajendran. So he used to tell us, if you have wheat flour, you can make chapati, puri, dosa, whatever you want, samosa, chilla, or anything. Okay, pakodi also you can make. So now I have a recipe with us, so I can play. Once I bake these particular powders, what we have done is, being a mechanical engineer with respect to having a laser micro manufacturing setups, what we try to do is we try to do go for laser coatings. The biggest advantage of laser coatings is you can coat 200 to 300 microns in seconds, or you can say in less than a minute. That is the basic advantage of the laser coatings technologies. Now you can see here how the laser coatings look like. For example, if your fluence is nothing but laser power per unit area. So if your power is less, so improper cladding or coating will take place. If you gradually increase and increase, what will happen? If you are going to have high amount, there will be a micro cracks and other things, because you are coating on a material which is an alloy, and your coating material is a ceramic, which is completely different. So this is plays a crucial role, because of thermal coefficient of expansion of two materials will be different. So once you understood this surface coatings, whatever you are seeing, we have to understand what is its surface anatomical structure. So surface anatomical structure means you need to go for cross-sectional analysis. Just cross-sectional analysis, and you can just see CL stands for coated layer and TL stands for transition layer. The normally transition layer is very good in terms of titanium, because titanium is having two big problems. One, it is poor conductor of temperature, or you can say heat. Second is it is highly reactive material. So if it is a poor conductor of temperature or heat, what will happen? The temperature or heat stays on the surface itself. That means that the material which is there on the top, coating material, will mingle for a large cross sections and other things. So once you understand that, then you have to understand what is the microstructures at the coated layer, microstructures at the interface layer, and other things. Okay, so you can see here how the dendritic structures are formed and other things on a functionally graded materials and other things. Now you can see here, we not only understand about the surface morphology. Being a mechanical engineer, we are very much interested in surface morphology, SEM analysis and other things, but sometimes we lack on elemental mapping of what are the elements that are present. For example, if you see here the bottom one P, this is complete elements. Okay, you can see here the pink one shows calcium, and P shows phosphate and other things. Titanium shows the yellow ones. You can see the density of yellow ones at the bottom is very high. Similarly, aluminum and other things also. So you should also understand the surface integrity. Surface integrity means surface morphology plus surface metallurgy. Surface metallurgy also plays a predominantly crucial role in terms of materials development. But so the basic problem in laser cladding system or laser coating system is that the surfaces are not accurate. The precision and repeatability is not there. You can see here at the same time micro cracks and other things are there. So this makes us improper fitting for orthopedic applications and other things. You cannot properly fix it. That is the biggest challenge. For that purpose, to overcome this, we have moved to another one technology that is called physical vapor deposition technology. So how the physical vapor deposition works? So this is completely a physical vapor deposition technique where we are taking the topmost only. So where we can check this chamber. So chamber will have two things. One is, apart from gas and other things, plasma and other things, one target, excuse me, one target as well as one substrate will be there. So target is the material that you need to coat. For example, here I want to coat titanium, if I want to coat on a hydroxyapatite on a titanium, so I have to make hydroxyapatite disc, from where the bombardment of rain of particles will fall like this. Okay, so you can see here the rain of particles will form and you can get the coating. So what about functionally graded here? So one of the drawbacks of titanium, which already explained, is it is highly reactive material. That means that whenever you are exposing into the atmospheric conditions, it will oxidize itself. But whether it is perfectly 100% coated or not, how do you check? For that purpose, what we have done here is we ourselves assume that there is a coating, so it may be improper. That's why we have coated with the titanium oxide first, which is now it is 100% perfectly coated one. Second, 25% of hydroxyapatite and 75% of. So only thing that you have to do is you have to make the disc according to it. Then 50-50, 75 and 25, then 100% hydroxyapatite. So you have to increase gradually the hydroxyapatite percentage. So the top hydroxyapatite layer will experience with respect to the body fluids and outside environments like bone and other things. The inner one major function is that it has to intact or it has to withhold the complete layer. So that is what the function is all about. So once you do all these coatings, you can also measure whether there is any change in the spectrum of XRD and FTIR and other things. You can clearly understand. So once you coat, you have to measure these coatings in terms of the porosity and other things. As you can see, the FGM, the porosity is much better. So we have also coated with respect to without any functional gradient also. The porosity is not there. Porosity is nothing but scaffolding nature. You need to have better scaffolding nature. So once you have all these things, being a mechanical engineer, you should be much worried about whether these coatings will sustain. As you have seen the early stages of the slide, so the dental is rotated, so it has to experience the torque. It has to may go shear force experiencing and other things. To overcome that, indirectly, there will be a delamination effect of the coating will take place. For that, what we have done is we have done the tribological test. So tribological test is pin on disc. You can say this test will give you the coating ability and other things. So we are going to change in terms of two. One is load ramping, another one is speed ramping. So you can change the speed with respect to each every 2 centimeters or 3 centimeters. At the same time, you can also increase the load. For example, 1 kg to 2 kg to 3 kg and other things. You can increase. So now we have checked with respect to our materials, and you can see the results here. So once you do the scratching on to the coating, and then you can go for EDS analysis, energy dispersive spectroscopy inside the scratch. Once you do the inside the scratch, if you are going to get a composition about calcium and phosphate dominating, that means that your coating is intact. If you are not going for that, or for example, if you have got the titanium, aluminum and other things in that circumstances, that means that your delamination has been occurred. So predominantly, as again says, that this delamination was evident, as you can see here. So this delamination was very high, and there is a brittle fracture happening, and this brittle fracture leads to the particles generation. For example, if you are going to put this one into the knee applications or any applications, what is going to happen? This will leach out the particles. So this may cause micropollutants and other things. To overcome that, so delamination has been occurred, for example, as you have seen here. So this delamination occurred. Why this delamination occurred? You have to go back and scratch your head and you have to understand. So the basic fundamental mistake that we have done here is that we have taken a titanium surface or titanium alloy surface. On top of it, we are coating on top of it. What is the disadvantage of this one? The disadvantage of this one is you are constructing a house without any basement. I mean to say that you have not at all considered the basement. Even though you have considered the functionally graded coatings, it is evident that you need to go for basement. That means that I need to construct the first basement, then I have to go for the construction of the house. So for that purpose, what we have done is PVD again, we are going back to the PVD only, but our knowledge for laser cladding system or laser coating system helps here. How it helps, you see here. Now, as I know that titanium is very highly reactive material. Second, it don't conduct temperature as good conductors. These two drawbacks are there. How you can convert drawbacks into advantage? So you do the texturing on top of it. Since the texturing involved temperature, and at the same time temperature won't conduct, so you will have a very good surfaces. For example, simple example, whatever the texture you are forming, you will have abundant amount of titanium oxide because it is a highly reacting at the room temperature itself. If you are going to do at high, slightly high temperature, what will happen? You will get a perfectly titanium oxide layer. So once you get this one, you have to understand how the molten material is taking place, how the textures are taking place, and other things. Initially, these are some of the problems that we faced. Later, we overcome those problems and other things. Once you do all those things, we have gone for texturing. So the texturing, you can see here how the texturing has happened. So these are different offsets. Zero overlapping, I mean to say beam overlapping, and 25% beam overlapping, and 50%. As you all see that the surfaces are predominantly gives you some of the super hydrophilic surfaces and other things. Okay, so there is any metallurgical changes and other things. What we have abundantly seen is that oxide film formation is predominant. So once you do the texturing and other things, you have to convince the community whether the surface is generated is hydrophilic surface or hydrophobic surface. So we want hydrophilic surface because you need to adhere properly. For that purpose, this particular contact angle measurement and other things done, and we have shown that this particular material after coat, after texturing and other things is hydrophobic surface, sorry, hydrophilic surface. Once you do hydrophilic surfaces, then you transfer this to the functionally graded coatings, which again, this is the same setup as you have seen PVD, but it is in a schematic mode where target is there, at the same time substrate is there. Substrate will coat by the target material on top of it. So now you can see here how the coating has happened onto the surface. So not only about the porous nature, but also you can see the metallurgical aspects, how the peaks are evidently and cleanly seen onto the surface and other things. Once these coatings and other things are successfully done, the second thing that you have to, being a mechanical engineer, we have to go for biological testing. So the first and foremost biological testing that you need to get is whether this material is biocompatible or not. So for that purpose, you can go for in vitro biocompatibility test. So this is called SBF test. SBF means simulated body fluid. So whatever the body fluid that you have in the body can be simulated into the laboratory scale, and this particular thing is used for these implant materials. For example, here our material, coated material, it is coated material is also white, but it is shown black because the hydroxyapatite layer is black and apatite layer is white. So this is because of the interaction with respect to minerals, proteins, and other things. These white layers are nothing but confirmation of your materials to go ahead, because your material is a confinedly a biomaterials and other things. Once you do this, you need to analysis in depth of the apatite layer formation, because apatite layer is purely a natural one, and which is formed by the virtue of interaction with respect to the both material, artificial materials and uh, artificial materials and natural materials inside the body. Once you do all these things, next step you have to go for is cell culture analysis. So in the particularly cell culture analysis, normally people try to do is, since this is particularly about orthopedic applications, we try to work out on MG63 osteoblast cells. So again, being a mechanical engineer, first and foremost thing that one can try is that you go for SEM analysis. SEM analysis won't give you a clear cut data that is evident from this particular picture. So you can see that cells are attached to the surface, but these are original cells or these are any foreign bodies like virus and other things. How do you know? So for that purpose, you need to go for another test called fluorescence microscopy. So you can see here fluorescence microscopy. So all green and orange colors you can see here. So how these green and orange colors will come? So the fluorescence microscopy will have some liquids. You need to put it. These are called dyes basically. So one is a red dye, another one is a green dye that you can give to the cells because of this osteoblast compatible things. So since the red one is superimposed by the green, you are looking like a orange. That's only the difference. So now what I mean to say is that using fluorescence microscopy, one can explain minimum to minimum three things from this one. One is whether the cells are growing or not. Okay, that is evident from the fluorescence microscopy. Second, any foreign elements are growing. For example, any virus is growing along with it, any bacteria is growing along with it. That also what. So third one, most important one is what is the cell density. Cell density means per unit area how much is there. So in these circumstances, what you can do is you can clearly measure the number of nucleuses in each and every unit area so that it will give you the density. Apart from these three, what you can also guess is you can also go for the pH test. So if the pH is increasing from a neutral, for example, when we are going to do the experiment, we try to do as much as neutral as possible. Now you can also see here nuclear area, cell adhesion, how the number of cells are adhering and other things that you can evidently see with respect to functionally graded material with respect to 100% hydroxyapatite. Functionally graded material gave a best results compared to the normal results also. Okay. So that is about the technical aspects of my presentation. So those people who are interested, they can go through some of my lectures in YouTube on Introduction to Machining and Machining Fluids. Second course is well recognized by across the globe. The first course, I can also say that first course is displayed in some of the industries for their employees. For example, Introduction to Machining and Machining Fluids. I came to know 1.5 years back that some of the industries are displaying my lectures from YouTube for their employees to make understand. So I'm very fortunate that when I listened from a person, one of the person who knows earlier to me because he was my junior in the Navodaya and he is heading one of the division in that company. So he sent me the screenshot that Anna, your videos are playing to our graduate trainees. Okay, so second is introduction to abrasive machining and finishing process. This is one of the best processes, best courses that is having a lot of registrations and other things. So those people who want to go through it, they can go through. And the third, this first and second is predominantly for UG and PG. And the third one I can suggest is for mostly either MS or PhD, those people who want to do. So third one, polymer, assisted abrasive finishing process and other things you can use there. So without funding, this is not possible. So I started my journey at IIT Guwahati with 5 lakhs. Then Baba Atomic Research Center about 23 lakhs. Then about DST nearly 1 crore. And DRDL about 75 lakhs. Then comes the big grant about 60 crores, which is currently as MIghty. At the time it was DITI. So nowadays it is MIghty. MIghty stands for Ministry of Electronics and Information Technology. Then comes Imprint to two projects, one with IAC Bangalore and one with IIT Kanpur, about 3 plus 3, 6 crores. Then IIT Tirupati about 22.5 lakhs. SERP recently gave about 45 lakhs and PIRAC about 40.1. Apart from this, I also have another one project from DRDL currently. And apart from this, we have received another big grant about 100 to 120 crores on technology incubation hub for IIT Tirupati, and where I am heading one of the vertical called precision manufacturing division and other things. So this is all about the funding. And second important thing is that you should have manpower. Currently, I have almost all 18 PhD students currently working under me, and 6 MS by research, and 3 MTechs and BTechs also. Okay, so this is what the strength of that. At the same time, you can see here, I'm very thankful for all the summer trainees who come from various institutions. Exclusively, I used to get when I was in Gauhati, or even nowadays because of this pandemic, we are not taking, but many of the people are doing online. So almost all 20 students are doing online. So as I said, no, again and again, I always think about what I have done for my home district. So in that case, at IIT Tirupati, IIT Gauhati, I can get maximum of 10 summer trainees per year. So out of which almost all 5 people I always take from my home district, because it is my responsibility to think about what I have given back to my home district. So people from Idupalpaya and other people are educated, so they regularly used to come to me. Okay, so rest all the 5 are, you can say 50% I can take from any NITs like NIT Surat, NIT Calicut, NIT, almost all the NITs, and some people so we are also very fortunate that we also get foreign people also. So many people think that all Indians will go abroad for summer internship. It is not so. Some of the abroad people also. Only thing is that you should have a good problems. I mean to say facilities and other things, and collaborations and other things. We try to get many people from abroad. So we have some of the summer trainees who visited us during the summer. So MTech, BTech, I'm very thankful for MTech, BTech, EMS, PhD, postdoc currently who are working and other things. So okay, so these are all about. And after seeing all these things, I would like to tell you 2 things. One, we are open for MS external and PhD external in the areas which I manufacturing area only. Okay, so if and only if you are from a government universities or government colleges or government research labs or government industries or anything that is relevant to government. Okay, and at the same time we are also open for providing the services, because IIT Tirupati now we are going to have very good state of art facilities in terms of SEM, in terms of TEM, in terms of anything, or in terms of facilities. For example, if you see the DMG Mori, I will display what are the facilities available in the next lecture, so that we are open for your research services also, because IIT Tirupati, we have an agenda to generate the revenue for upliftment of IIT Tirupati also. So you can always come and do your work. So with this, I am very thankful to JNTU Pulivindala for giving the opportunity to showcase what we try to do. And whatever I shown, this is completely belongs to only one student out of my 21 students. Thank you.
Thank you, sir, for your nice lecture. And I request all the participants to update the attendance for today. The attendance link was already posted, so please look out the link. Thank you, Ravi Shankar sir, for presenting.
If they have any queries, I'm happy to take up.
Okay. Please, participants, sir is requesting for questions. Participants, hello, participants,
So there is no query.
no queries. Okay.
Yes, sir.
You may be not having, some other person might be having.
So where is the attendance form?
Already the link was given.
So where, through mail or where?
No. Google link was sent, in the messages you can see.
No,
Forms
sir, I am not. Sir, in this chat box or in the WhatsApp group,
chat box.
I am not able to see.
Sir, 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 participant, sir, sir, we have posted the Google Meet link, sir, for the participant.
Sir, you please share that link in the WhatsApp group.
We will share it in the WhatsApp group, sir. There is a small technical issue. We will solve it by a couple of minutes, sir.
Because I was also not able to mark my attendance yesterday.
Yeah, I will leave now. You can carry on, please. Thank you.
Thank you, Ravi Shankar sir.
Can I
Thank you.
leave now? Can I leave
Yes,
now?
sir. Yes, sir.
Thank you. Hope to meet you again on next call.
Okay. Okay, sir. Thank you, sir. Now the attendance link is active. You can give the attendance link. Dear participants, now you can give the attendance in the link is provided. Huh? ఈయన ఏందో సరే ఆడుకుని ఇంకోపోతాడు కరెక్ట్ టైం ముందు ఏం కాదులేదు సార్ ఇంకా అయిపోయింది కదా వస్తుంది కదా
పవన్ మ్యూట్ చేసుకోండి.
ఈయన కొట్టబ్బా అబ్బా ఇది కొట్టు
ఈమెయిల్ ఐడితో
ఇది కొట్టు ఇది లింక్
Shall we leave the meeting, sir, now? Submitted my attendance.
Yes.
You can leave. Those who have given the attendance, you can leave.
Sir, yesterday I was not able to submit my response on the time. And when I clicked on the link and it showed that you need to take the permission or session expired.
Okay, tomorrow I will look into that issue, sir, after some
Yes, sir.
time. Okay.
Okay,
Don't worry.
thank you, sir. Okay. Okay, thank you, sir.
Thank you. ఇది వచ్చింది కొట్టు
వద్దులేండి సార్, ఇది కాదు నాది ఉండవు.
నేను చెక్ చేసుకుంటేది అయిపోయిందా ఎక్కడ
అంతే
నిన్న ఇచ్చిన దాంట్లో అటెండెన్స్ ఇచ్చిన కదా మళ్ళా కొట్టి సబ్మిటెడ్ అని వచ్చేది. ఇప్పుడు మళ్ళా కొట్టన్నా వస్తాను. ఏం కాదు, వచ్చింది. పార్టిసిపెంట్స్ ఎవరెవరు వస్తున్నారో ఒకసారి చూసుకోండి సార్. ఎందుకంటే మనం అందరికీ యాక్సెప్ట్ కొట్టలేము.
మళ్ళీ కోర్స్ సెకండ్ కూడా ఇచ్చిన అందుకే ఆ లిస్ట్ కోసమే నేను పెట్టింది. మీరు ఏదైనా పిలిచి ఒకసారి ఆ తిక్క తిక్క లింకులు కాకుండా ఒక లింక్ పెట్టమన్నా దేవుడిని.
ఏం కావాలి సార్, వస్తాయి వస్తాయి. పోతే 71 రెస్పాన్సెస్.
నిన్నటిది ఈ రోజు సమయం ఇది.
అవును,
నిన్నటిది ఎట్లా తెలుసుకుంటేది మనం? నిన్నటిది ఎట్లా, ఈ రోజు ఎట్లా అని?
మెయిల్కి వస్తాయి సార్. ఏ రోజు ఆ రోజు మెయిల్కి వస్తాయి సపరేట్గా. గూగుల్ ఫామ్ మెయిల్కి సపరేట్గా ఎక్సెల్ షీట్ డౌన్లోడ్ చేసుకోవచ్చు.
ఇప్పుడు ఇది టైం ఉంటుంది. నిన్న 10:04, ఇది 10:05, 10:05 నుంచి ఇది
దీని నుంచి
5 నుంచి 49 మంది, 76లో నుంచి 49,
27
27 ఉంటుంది. అవునా? అంతే కదా?
అంతే.
అది చిన్న ఇది అన్నం ప్రదీప్ ఉంది, చంద్రశేఖర్ రెడ్డి, విష్ణువర్ధన్, కేసీ కాలేజ్, ప్రాణేశ్వర రెడ్డి, ఆనందిని, ఆగ్రా, శ్రీధరస్వామి, తిరుపతి, గీతం, పవన్ కుమార్, వర్ధమాన కాలేజీ, సాగర, 77 అభిషేక్. చేద్దానా ఏం చేయాలి? స్టాప్ చేద్దానా?
అప్పుడేనా?
I request the participants to go into the Google Forms or to the link which I have provided to give your attendance, because 80% attendance is required to permit you for an exam. Suresh, are you available? I request all the participants to give attendance in the link, that is today's attendance link, forms.gle. Something it was written, and I have shared it in chat box. So please go for it and give the attendance. Venkat Reddy, you are trying to say something?
I am unable to get that link, attendance link.
No. You will be getting. Check it once again.
When you have joined, correct?
In chat box you have placed, sir, where it is?
Again, I am placing it. Check it.
I did not receive it, sir.
Now,
Now I got it, sir.
yes.
Thank you, sir. Now I am filling.
Nilesh Dalia. You fill. Ask your friends also to fill. Sridhar Naidu. See, without attendance, I can't able to give you or I can't able to permit you for the exam. You need to give. I need to show 80% attendance that you are eligible for the exam. So only option is to mark an attendance in the attendance sheet. So please link into it.
Yesterday also I faced the same problem, sir. Yesterday also I faced the
What
same problem.
Venkat? Okay, now you are not facing right.
Yeah, I am filling, sir.
Getting right. So you mark the attendance.
Sir.
Shiva Saktivel, Sridhar Naidu, Radhika Grandhi, Nagendra Singh, all those people need to give. Chandrasekhar Reddy,
Sir. Good evening, sir.
Good evening, Chandrasekhar Reddy.
Sir, I filled the attendance.
Sheet. Okay. Ask your friends also to fill the attendance sheet.
Yes, sir.
Okay, Chandrasekhar Reddy.
Okay, sir. Thank you, sir.
Thanks for attendance.
Thank you, sir. Thank you. Welcome, sir.
Shesha Narasimha, Khalil Mohan, Abhishek Yadav, Suresh Kilaparti, Irfan Khan, Nilesh Dalai, Suresh Kilaparti 2 times came. Okay. So,
Sir, I have given my attendance, sir. Suresh
okay.
Kilap.
Okay. So I request everyone to give the attendance because 80% attendance is required. Okay. Almost good lectures I bought to teach in your class. So anyway, it is online. You can able to sit at your house or in the college. You can in middle you can be free to move here and there. So best opportunity I feel. So it was the certificate will be given by AICT approved one. without much problems. The problem with online was solved. Hope everyone. What is your feedback about the session, Chandrasekhar Reddy?
Sir, it's excellent, sir. Excellent. It's going on good.
Okay, Chandrasekhar Reddy, thanks for your.
Yes, sir. Yes, sir. You arranged a very well-known professors, and they are
Okay.
giving very best of their knowledge, sir.
Okay.
Thank you, sir. Thank you.
Excellent, I can't able to, but I tried to become excellent.
Yes, sir. Yes, sir. Yes, sir. Okay, sir.
Okay, still will you?
Yes, sir. Yes, sir.
Ah.
Completed.
Okay, tomorrow's session will be at 9 o'clock.
Okay, sir.
Tomorrow's session will be at 9 o'clock, same link, and Chandrasekhar Shastri will give the lecture. He is from IIT DFM Karnool. Okay,
Okay, sir.
thanks to one and all.
Thank you, sir. Thank you.
Thank you.
Thank you, sir. Thank you so much.